In the previous video, we discussed the nature of parallelograms. Parallelograms are quadrilaterals with both pairs of opposite sides parallel. In this video, we will analyze the rhombus, which is a more particular type of parallelogram with some unique properties. The main difference between a rhombus and other parallelograms is this. All four sides of a rhombus are congruent. If you recall from the previous video, each side of a quadrilateral must be congruent with its opposite side to be a parallelogram. The two shorter sides were congruent, and the two longer sides were congruent. Rhombi are more specific though. All sides must be congruent. However, rhombi inherit all the other properties that we discussed about parallelograms in the previous lesson. The rhombus does have a few unique characteristics to bring to the table. These characteristics come in the form of two theorems. For one, not only do the diagonals bisect each other, but the diagonals also form a perpendicular angle at their intersection. Additionally, each pair of opposite angles are bisected by a diagonal. This means that each angle on the rhombus gets cut exactly in half when a diagonal is drawn through it. We will now examine three conditions that you can use to logically conclude whether a parallelogram is a rhombus. Each one is related to the properties we just discussed. Don't forget that these conditions only work if you already know that the shape is a parallelogram. If not, these conditions won't always work. Condition number one. If you are given that a pair of consecutive sides of a parallelogram are congruent, you can conclude that the shape is a rhombus. If any side happens to not be congruent with another, the shape fails to qualify as a rhombus. Condition number two. If you see that the diagonals form a perpendicular intersection, the parallelogram is a rhombus. If this does not occur, the four sides fail to be congruent with one another, and therefore, the shape is no longer a rhombus. Condition number three. If you see that at least one diagonal bisects the angles on each end, the parallelogram is a rhombus. A diagonal does not bisect the angles when the sides are not all congruent, which means the shape is not a rhombus. Now we will examine three parallelograms to test if they are rhombi. Remember, parallelogram only needs to pass one condition for it to pass the rhombus test. Example number one. Here we have a parallelogram with information only about its two sides. Looks like they are congruent. With this information, condition number one is satisfied, so the shape must be a rhombus. Example number two. Our next parallelogram has its two diagonals drawn on top of it, with their angle measures displayed at the intersection. What's wrong with this picture though? Condition number two says that the intersection must be perpendicular. Therefore, since the diagonals of the shape are not perpendicular, the shape cannot be classified as a rhombus. Example number three. Our final parallelogram is a square with the diagonals bisecting the angles at each vertex. Without the diagonals, squares have 90-degree angles at each vertex. With each angle being split into 45-degree angles, we know for sure that the diagonals are bisecting each vertex, since 90 divided by 2 equals 45. This satisfies condition number 3 and proves that squares are rhombi too. If you remember from our last video, we discussed that a square was an example of a parallelogram as well. A square is a rectangle, a parallelogram, and a rhombus, all in one shape. Finally, we will discuss how to calculate the area of a rhombus. There are at least two ways to calculate the area of this shape. The first is the standard formula for the area of a parallelogram, which is A equals B times H. However, due to the nature of the diagonals, a second formula can be used. Rotating the rhombus and drawing its diagonals to see their perpendicular intersection will be helpful in understanding this new formula. We will call the long diagonal D1 and the shorter diagonal D2. If we make a copy of this rhombus and slice and rotate these four triangles and add them here, we have now made a rectangle that is as long as D1 and as wide as D2. If the area of the rectangle is length times width, which in our case is D1 times D2, then the area of one rhombus would be half of that value, since the rectangle took 2 rhombi to construct. the formula for the area of a rhombus is also area equals 1/2 times d1 times d2. For example, if d1 was equal to 3 units of length and d2 was equal to 1 unit of length, then after plugging in our values, we would have a equals 1/2 times 3 times 1. 3 times 1 equals 3, and 3 times 1/2 equals 1.5 square units of area. Don't forget that the area can still be calculated using a equals base times height. And the reason why you can still use this one is because a rhombus is still considered a parallelogram. And that concludes our lesson on rhombi. In the next video, we will explore the shape of trapezoids and their special form, the isosceles trapezoid.